Hi, it's Liliana,
I'm Haley.
and we're back with going over energy. So first, we have a couple of questions so how do you survive a head-on collision? So first, you're gonna want to reduce your speed and obviously avoid at all possible. If not, your crash zone is gonna be the front of your vehicle, so you should make sure that you're calm, collected, keep slowing down, and try and remove yourself from the front of the vehicle.
And then, how do you win an egg drop contest? So, to win an egg drop contest, you must protect the egg by using physics principles as well as protecting it by putting like some type of foam or a type of like cloth just to protect the layer so that it slows down or it absorbs the impact of force upon landing.
Okay, so we're back. We're gonna be doing an experiment here. So I have this piece of paper that we folded in half to make a groove, and here is our triangular stopper. We're gonna actually let a marble go down it, and however much it pushes, how far this pushes, we're gonna measure that, and then we'll end up making a table. So just for an example, this is what it's supposed to look like. Now to actually do the experiment, I'm gonna go ahead and have this ready here. Go ahead and roll my marble down. Okay, so it looks like it went a whole 12 inches. And I would say 4.5, so let's see, 16.5 inches from point A to point B. Okay, so now we have 2 blocks here, so it's about 3 inches high now. And we're gonna also see that go down and then put that into our plot, which we'll show at the end. So that was a fail, so we're gonna try it again. Okay, so as you can see, the marble kept going. And we're just gonna say that since the first time was right here, we're gonna say it all went all the way down there. Okay. So now we have 3 blocks. So that is about 4.5 inches high now. So now using this is our friction. We're just gonna go ahead and drop it down one more time. Ooh, I messed it up.
Okay, we'll try one more time.
Yep. Trying again.
Gave it more kinetic energy, more potential energy, which gave it more.
Okay, so as you can see on how hard that bounced off and it went completely over it, the potential energy and kinetic energy, you can see it was significantly higher to make it bounce and fall harder.
And we can also tell that the higher our ramp gets, the faster the marble travels.
Yes.
So now we're going to try this with a different marble, which has, I think, a heavier mass. So
Now we're going to do the same experiment.
So we can try that again just because this paper moved. We're going to put it a little bit closer.
Okay. Nice. I didn't even laugh at them.
There we go. And as you can see, it stopped right here. And it stopped because we have this, but also you can see that since it was right in between, it slowed down, and then once it hit that, it completely stopped. Try one with a little bit lighter mass than the last one, which was this one, but it's a bit heavier than the first marble that we used, so it's right in between. So we're going to set up our little ramp like this, and then we're going to drop this one. Which didn't work. Okay, let's try that again. Alright, and as you can see, this one stopped not really halfway, a little more than halfway, but it is 30 centimeters. Oh, 30 inches.
12 inches.
12 inches? Wait, we're going to use this marble, which is a little bit heavier than the first one, but a little bit lighter than this one that we used.
Alright, so
just drop that. Okay, let's redo that so that we can catch it in this thing.
So what you can see here is
Alright, so it stopped right there. So 12. It's about, I want to say 30 inches, about there. Okay, sorry guys, I messed up the measurements. It's actually about 19 to 20 inches away from the ramp.
Okay, so here we have our two plots. This is our height plot and our mass plot. So honestly, they both ended up about the same way, depending on the heaviest marble here to the lightest. And then as they got higher, they also went down faster and harder. So I feel like with height, it had a lot more kinetic energy in it because it fell harder than what the mass did, because the mass was more at a standstill and was able to slow down faster.
Okay, so now we're gonna do basically the same thing, except we've got a much bigger ramp, a bigger stopper, and this time we're doing it with a toy car. So pretty much just what we did. So we're gonna see how this works. Ooh, let's redo it. Okay, so we're gonna try that again. Except this time we added something at the end so that we could keep it from falling off the table. Alright, so it's gonna start right up here. Okay, so we can try that again just because I think I put it a little more off to the side and it needs to kind of be more at the center. So let's try that again. I'm gonna kind of measure it. Okay. Okay, so we're gonna give that one more go.
We're just going to leave it at that, and we're going to measure the whole entire thing because that's where it keeps going to. Okay, so now we're going to do it with 2 blocks instead of 3.
That worked. Okay, so that stopped about, what do you think? This was,
Well, let's just do this.
I think it was about
1, 2, so probably about 24 inches. Okay, so now we are at 1 block here, and we're collecting our car and setting up real quick.
Okay. So yeah, like she said, we reduced it to 1 block. As you can see, it was a lot slower, and it stopped a lot earlier than the other 2.
Yes, and so as you can see, we're probably about 6 inches right there, just between at the end of the car to that. And so as you can tell, it had gotten a lot slower as the blocks went down as well. So here's our plot. So as you can tell, we have our first block, 2 block, 1 block, 2 blocks, 3 blocks, 1 fish, 2 fish, 3 fish. So we have our numbers here. These are in inches, and as you can tell, when we only had 1 block, it only went about 6 inches. Our second, 24, and our third, 36. And these 2 up here roughly estimated with using our toy car. And so as you can see, it looks a lot like the other ones that we did, and we didn't have. You can tell as soon as it got higher, we didn't have much friction at all. Okay, so now we are trying to find the force friction, and so we have our mass times gravity times height. So we're going to take 22.753 times 10 times 3, which equals 682.59. 0.59, and as you can see, we just used that last go around when it had completely stopped between here, and that making that 6 inches. Okay, so as you can see, this was our toy car and this is our block, and I only got the information I needed. It was up and then it fell, but that is not needed anymore. So this is how far the block had traveled, And so we are going to take our mass, and Haley's gonna go ahead and use her calculator.
Yeah. Okay.
And then we have 15.808 times 10 times 20. And so the friction was 3,161.6. And this would be our friction force, in which at first when we had it regularly, it would not let us it would not roll down because there was too much friction here in the block. So Haley, will you please demonstrate where the top of it was at?
Yes. So the top of it was right here.
The top of this block, so making that angle.
Yes. So it went from here all the way to here, and the reason this was able to slide down was because of the height of the rail.